Okay, sorry about that. I'm trying out a new method on YouTube to set up the stream, which hopefully in the long run will make it easier and better. But I forgot to press the go live button on it. So here we go. We're going on this. Here's the question that we're looking at. Richard sponsored to cycle 1,000 miles over a number of days. He cycles 10 miles on day one, increases distance by 10% per day. So day one, we got 10 miles. Day two, we got 10 times 1.1, because that's increasing it by 10%. And then on day three, we're going to increase by another 1.1. So we're going to times by 1.1 squared. And you see we have a geometric. And we want to see how long it takes him to do 1,000 miles. So we're going to sum this geometric. So we're going to sum the number of days. So we don't know how many days. That's going to be equal to, if we work out what the first term is, A is 10, and the common ratio, what we're timesing by each time, is equal to 1.1. So Sn will equal 10 times 1 minus 1.2 the n over 1 minus 1.1. Now we want to find out when this is greater than, when it gets to 1,000 miles. Let's rub that out and replace it with 1,000 miles. So we're going to take 1.1 away from 1, and then times by that. That's going to be minus 0.1, so we get 1,000 times by minus 1 equals 10 times 1 minus 1.1 to the n. Divide that by 10, so we can, times that by minus 0.1, going to be minus 100, and then divided by 10 is going to be minus. Now what I'm going to do is add this to this side and add this to the other side. So I get 1.1 to the n is equal to 10 plus 1, which is 11. Then we take logs of both sides. And to save space, what we realise, log 1. Well, I won't save space. I'll write it out properly. What we're going to do is we realise that this is just the same as n log 1.1 log of 11. That's one of your logarithm laws. If you don't know it, you need to go away and learn it. So therefore, n will equal log of 11 divided by log 1. Calculations. I didn't put the calculator. Bring up my calculator here. Scroll back to where I did this question. Okay, so we've got log of 11 divided by log of 1.1 gives us 25.15. Okay, so it's going to actually take more than 25 days, so n will equal 26 is going to be a number of days it takes for us to get to 1,000 on the 26th day. Now we want to know the greatest number of miles he completed in this day. So that is likely to be on the 25th day because we've only got the 0.15 of the 26th day that he's going to actually cycle. So what we can do is we can find out 25th day. That's going to be this term, 25. So it's 10 times 1.1, 24. On the 25th day, we get 10 times 1, 4. Grab my calculator. And you can see I've already worked that out, and I got 98.9. Then what also I did do, just to check, I then summed the first 25 days, and I noticed at 983, there's only going to be just under 17 miles, okay, 17 miles that he'll cycle on the last day, which is obviously less than 98. Just wanted to check on the last day, didn't get more. I worked that out. So we get it's equal to 98.5 miles 3SF. Okay, so that's how we question. Right, we've got one more question. Another geometric question, same style. So you should be able to get through this a lot more quickly. So here you go. Have a go at this question. 2 minutes to start you off. There you go. Right, so let's look at this question. Now, I'm going to be really careful about this question. We got here is they can, if all say it's £500, which he deposits on the 1st of January, okay, and the interest is paid on the 31st of December. So, ways to set this up. You can either set it up to talk about January year one, year two, year three, or December year one. I'm actually going to look at what's the amount on 31st of December each time. I just think it's a little less confusing because it doesn't. Yeah, it just makes it easier to work out at the end of the year, and then you know at the beginning of next year you add on £500. When it comes to deciding whether you've gone above or below the 20,000, be the critical part, because you don't know the interest times the current amount when summing as easily as you do know adding on £500 the next day. So what we're going to do is we're going to look at the year one, the 31st of December. Okay, and year one, the 31st of December, you'll have the £500 in, but also it'll have had the interest paid on it. So it'll be times by the 1.035. So that's how much is in the account on the 31st of December, year one. Then on the 31st of December, year two, there's going to be another £500 added on. And then that's going to also have interest of 1.05 from the whole of that year added on to that. Then this year is going to have interest of 1.3035 added on to that. So you could times by another 1.035. So we get this amount times by another 1.035. So that's effectively 1.035 squared. And then on that's the amount we have at the end of year two. And at the end of year three, I'm going to actually move down a bit. Space. I'm going to have the same thing happening again. So add on another 500 times 1.035 for the 500 deposit beginning year plus its interest. Then this is going to have that times by 1.05 again. That becomes squared. And now we're going to have this one. It's going to have another load of interest put on. And that's going to become cubed. So this is what we get at the end of year three. So our first term, we're getting the sequence. It's going to be 500 times 1.035. And then we're going to times this by each time 1.05. So AX 500 times 1.035. And this is R is equal to 1.5. So our sum, which is going to be 20,000, looking for when that is equal to this times 1.035, which is 575 times 1.035 to the n minus 1. Notice I've written this in a different order just to show it doesn't matter which way round you write them. It will give you. But this will lead us to not having so negative numbers later on in the question. So if I pull up my calculator to do some of those calculations, you can see I did that division. Roll to the right point. So I then did 20,000. Then did the 5175 divided by the 0.35. 1.3035 minus 1 is 0.5. Do that divided by that to find what we're timesing by, which is 14,705. So we're going to have here 20,000 equal 7, 8 rest times by what brackets here 1. So I'm going to divide by that. So 20,000 divided by 4,785 and the rest equal to 1.5 to the n minus 1. See, that comes out as 1.3526, roughly 1.5 equal to 1.035 to the n 1. Add on 1, we get 2. Remember, there's a lot more. N. And then hopefully you remembered we've got to do logarithms again. So let's take logs of both sides. Right. And then that n will come down here. That logarithm. Divide both sides by log of 1.0. N. Grab my calculator. See that I've already done that. And we get, when we do that calculation, we can see I've done the 1.3 plus the 1, then I get 24.6. Equal to IN. So let's just go back up and have a look. So we're looking for how many years before he saved up the 20,000. So it's going to take 25 years because at the beginning of the 24, he's not going to have enough. It's going to be the end of his 25th year. The N will equal 25 when he's got more than his 20,000 pounds. Okay, so that is our answer to that. We don't need to work out the most, we just work out how many. We know that if you have n as 24, the sum's going to be less than 20,000. Therefore, take the. That's the end of the 20th year because remember we did it on the 31st of December to take how long it's going to take him to pay off his £20. That's all we've got planned today. Those are all the questions that were sent in. So there we go. Some geometrics. If you're in the if you're doing A-level IB, that should hopefully give you a help. I found that useful. Do send in some more questions. Goodbye.